Good morning, everybody. Welcome back to my video. I'm Anusha, working as Assistant Professor in Computer Science and Engineering, Institute of Aeronautical Engineering. In my video, I'm discussing about the subject Programming with Objects, which is based on Java. So, in the previous class, we have discussed about exception handling, wherein we have discussed the importance of and where we use throw and throws and how we can rethrow any exceptions. In today's class, we will be looking into finally built-in exceptions and how we can create our own exceptions. So let's move on to our video. Now, so as we have seen before, for exception handling we had used 5 keywords, wherein we had the try-catch block, the throw and throws, and the finally keyword. So these three they come together. So for any try block, we can have a catch and a finally block. So either we should have a catch block or you should have a finally block. So if we are handling any exception with a try block, then you need a catch. Either you need a catch block or you should need a finally block. And as we have seen, all those code which we create, which we have to look out for exceptions, we put it inside the try block, and the handling mechanism, the solution for those exceptions may be provided in the catch block. Now there may be a set of statements which we need to execute compulsorily, like the set of code which we have to execute for sure. So such statements we will keep inside the finally block. So whatever statement we place inside the finally block will be definitely executed. Only then the try block will be exited. The try catch block will be exited. So and also if we have any finally clause, then that inside a method, and that will be executed before the method returns. So if we want to have any set of statements which has to be executed definitely, then we put it inside the finally block. So one try block can have at least one catch block or a finally block. So this is the syntax. We have the try block, try and catch, and the finally. This will come at the end. After the catch block, we will have the finally block. So this catch block or the finally block are optional. Either it can have a catch block or a finally block, or it can have both. Now let's look into an example. So wherein we have 3 methods: procedure A, procedure B, and procedure C. All these are some methods which has been called inside the main method, and they are having some mechanism to handle the exceptions thrown. So inside the procedure A, we are having a try catch block. This try catch block is having a finally clause also. So inside A, we have a exception handling with try, catch, and finally. Then we have the procedure B inside procedure B, inside which we have a try block and a finally block. Here inside this we have the return statement also. We'll see how it will work. And inside the procedure C, we just have a try and a finally block. So here we don't have the catch block, we just have the finally block. So all these ways are acceptable in Java. So now inside procedure A, we have this try block. So inside the try block, we are manually throwing a runtime exception, which is given the name, the exception statement demo. So we are throwing a runtime exception. So first it will print the statement and then it will throw this runtime exception. So once this runtime exception is thrown, it has to be handled by someone. So we have the catch block to handle that runtime exception. So here we have the runtime exception object thrown that is being caught inside the catch block in the object E, and we are displaying it. So what will we get? We will get it is displayed inside the what you say, that exception object thrown from here is caught inside E and it is being displayed. Now we have handled it. Now since we have this finally block, the statement procedure A is finally, it will execute the set statements inside the finally block. So we will get the output procedures A finally in the output. Now inside procedure B, we have a try and a finally. We don't have the catch clause. So it will we are first printing that statement, one statement, and then you are returning it. So when you execute this return statement, what happens? The control will go from the executing method to the call method. So it will go, this procedure B was called from main. So inside, once this procedure B, once the control executes return, it has to go back to the call method. But here we have the finally block present. So since we have the finally block, this return statement will be executed only after the finally block is executed. So this statement will be displayed in the output. Only then the control will be going back to the main method. So inside procedure B, we have this statement will be displayed in the output. This statement, the finally block also will be executed, and the statement inside the finally block also will be displayed, and then only the statement of return will be executed. So you get all these two lines in the output. Now inside procedure C, we just have a try and a finally block. So it will display the finally try block statements, and you get the output here you get the output in the output screen. And finally, this statement also, the finally block is executing over here. So this statement also will be displayed in the output. So that is why we get, see here we have procedure A, inside procedure A. So first what is happening inside the main method, we have procedure A called inside the main method. So when the procedure A is called, it will go into the procedure A. First the statement inside procedure A is printed. Then it is since it is manually throwing an exception, that exception message will be rewritten. A runtime, instead of the default runtime exception, it is rewritten as a demo. So that statement will be displayed in the output. So in the output, we will get this statement. When you display this exception object, we get this whole statement in the output. Because we are throwing a runtime exception, and that runtime exception comes under Java Lang runtime, and we have given our own error message as demo. And then it is, procedure A is executed. So finally block also will be executed. So after displaying the error method, you get this line, procedure A is finally. So these three statements we got from procedure A, from the method proc A. Okay. Next we have, so once this method is executed inside the main, since the exception is handled properly inside the procedure A, there won't be further movement of the exception object. So the statement will not be executed. So next statement will be the procedure B. So once procedure B is called, it will print these two statements. So as I have told, it will first execute the inside this display statement inside procedure B. So we get inside procedure B, and we have a return statement. But before executing return statement, the finally block will be executed. So the finally block statement will be shown in the output. So you get the finally block output of B, and then it will return. So once this finally block is executed, it will return, and the control will come at this point, and then it will start executing procedure C. So once procedure C is executed, what happens once procedure C is executed? It will go inside procedure C. So inside procedure C will be displayed, and procedure C's finally also will be displayed, which is available inside the finally block. So we can have a try-catch block. We can have a try-catch block, or a try-finally block, or a try-catch and finally block. all these combinations are allowed. Next, let's look into Java's built-in exceptions. So what are built-in exceptions? Exceptions I already told, we can have, it can be either built-in, or you can have your the user, the developer can build their own exception. So till now we have seen most the exceptions thrown and handled are mainly defined inside the JDK. So it is all these exceptions are defined inside the Java lang class. So we have runtime, we have these runtime exceptions, as well as that means we have the checked exceptions and the unchecked exceptions, and we have the Java's runtime exception classes defined inside the java.lang packages. So these are some of the exceptions being handled by the built-in exceptions which is available inside Java. So an arithmetic exception will be thrown when the code is dividing some performing a division operation by 0. So when there is a division by 0, the arithmetic exception will be thrown. Now array index out of bound exception will be thrown when you try to access an element which is outside the bounds, outside the array index. Like for example, if we have an array of 5 elements, we are trying to access the 6th element, then it will throw array out of bound exception. It will throw the array out of bound exception. Next, array store exception will be thrown when we try to assign an array element of an incompatible type. Like for example, we have a, let's say we have a integer object. We have an integer class, wrapper class integer object, and into this we are trying to store a double wrapper class object. Then it will throw an array store exception. Or you have an integer type array and you are trying to store a string array into that, it will throw an array store exception, because it is trying to store an assignment. You are trying to store an element of incompatible type. Next, we have the class cast exception, which will be thrown when you try to give an invalid cast. Like you have an string object and you have a string and you are trying to cast it as an integer. So in such cases, it may throw an invalid class cast exception. The next is Unconstant not present exception. This is thrown when an attempt is made to use an undefined enumeration value. When you try to, we have this enumeration constants, right? So when you try to use an undefined enumeration value, then an unconstant not present exception will be thrown. Next, we have the illegal argument exception. This exception will be invoked when you try to use an illegal argument. When an illegal argument is used to invoke a method, it will be thrown. This illegal argument exception will be thrown when you try to pass or invoke a method with an illegal argument. The next one is illegal monitor state exception, wherein illegal monitor operations such as waiting on an unlocked thread happens. Next is the illegal state exception, wherein it will be thrown when the environment or application is in incorrect state. Then we have the illegal thread exception, where it will be thrown when the requested operation is not compatible with the current state. Then we have the index out of bound exception. So this type will be thrown when the index is out of bounds. The negative array size exception will be thrown when you try to create an array with a negative size. Null pointer exception will be thrown when you try to use an invalid when you make an invalid use of a null reference. When you make an invalid use of a null reference, null pointer exception will be thrown. Next is the number format exception, which will be thrown when an invalid conversion of a string to a numeric format is done. Then we have the security exception when it will be thrown when you attempt to violate the security features. Then string index out of bound will be thrown when you try to attempt to index an element outside the bound of the string. And type not present exception will be thrown when that particular type is not found. And unsupported operation exception will be thrown when an unsupported operation was encountered. So these are some of the unchecked runtime exception subclasses defined in Java. Let's look into some few examples. The first one is array store exception. So as I've told you, when array store exception will be thrown when you try to store an element of an incompatible type. For example, here we are creating a array of number type and we are creating an array of double type. So when you try to store into double array, we are trying to store an integer. So at that point, what happens? This will throw an array store exception because our array was of type double and we are trying to store an integer element into it. So which will be an exception in Java, which will be an array store exception. Similarly, a class cast exception is thrown when we try to improperly cast a class from one type to another. So for example, let's say we have an element of object class and we are trying to cast it to a string. So this is an incompatible operations. If you try to do so, it will throw a class cast exception. Now, similarly, we have some of the checked exceptions. These are all some checked exceptions defined in Java, wherein we have the class not found, where it will be thrown when the class we're trying to access is not found. Then the clone not supported exception, when we try to attempt to clone an object that does not implement the clonable interface. So when we try to implement a clone, when we try to create a clone that does not implement clonable interface, clone not supported exception will be thrown. Illegal access exception will be thrown when you try to access a class who is denied. Like you are trying to access a class in which you don't have the right to access it. So in such cases, it will throw illegal access exception. Next is instantiation exception, when you try to create an object of an abstract or an interface, abstract class or an interface. You cannot create object for such things. So when you try to create an object for such classes, such abstract class or an interface, it will throw an instantiation exception. Then we have the interrupted exception, when it will be thrown when one thread is being interrupted by another thread. Then we have no such field exceptions, which will be thrown when the requested field does not exist. And no such method exception will be thrown when the requested method does not exist. Like you are trying to access a method which is not defined inside our program or inside JDK itself. Reflexive operation exception will be thrown when the superclass of reflection related exceptions are created. So these are some of the checked exceptions, built-in checked exceptions defined in Java. Now there are cases wherein the developer himself wants to define their own exception. So there may be chances wherein some operations may occur wherein that type of exception is not defined in Java, or the user himself wants to define some own exceptions. So when you try to create your own exceptions, those exceptions can be those exceptions are Java allows you to create your own exceptions. So when you want to create our own exceptions, we always define a subclass of the exception class. So we always we inherit the exception class into that particular exception. Wherever we want to define our own exception, we will create our exception by defining a subclass of the exception class. Now the exception class is also a subclass of throwable. So all the methods which is available inside the throwable will be made available inside the exception class also. So we can override all those methods according to our wish. We can override the methods inside the exception class obtained from the throwable class, and we can give our own description for our exceptions. So generally we override the toString method available inside the throwable class. So the toString method, they generally convert it into the string format of that object, of that particular object. So whenever we get a whenever an exception object is being thrown, we get this messages because of the toString method inside it. So this toString method, it will convert that exception exception object into its string form. So for example, if it throws arithmetic exception, that arithmetic exception is defined as division by 0. It is defined as division by 0. So when it is given division by 0, I mean, this is the this is what it will be defined inside the object. So this part is being converted into string format and is being displayed into our output. So here we just, what we do when we develop our own exception, we just override the toString method, and we can change the look of or the format of this into our own way. Like we can give our error messages to be displayed in our particular way. So that is how we create the exceptions of our own. Now let's look into an example. So let's look into how we are defining our example, how we are creating our own exception. So as I've told you, when we want to define our own exception class, we have to inherit the exception class. So here we are creating an exception named myException. So this is the part wherein we are describing our exception. So it has to extend the exception class. Now inside the exception class, we have this is our constructor. So whatever message is being defined by us at the time of exception, that has to be that will be taken at this point. It will be taken at this point, and then we have to display some message of our own, right? So when we have to define our message, we can edit that particular exception in this way. So we are adding some exception, some statements of our own into it. Now when we are creating our own exceptions, we have to manually throw that exception, right? Whenever if that problem occurs, then you inside the try catch block, or whenever we are trying to, so whenever we there is a possibility of the exception which we have defined can be thrown, then we have to throw it manually, right? Okay, we have to throw it manually. So here we have defined our exception. Here we have defined our exception, and we are overriding the toString method to define our exception, right? Now inside the main method, we have the try catch block. So inside the try block, we have the set of statements what we have to what we are checking for error. So our statements, and so we have to ask, since there is an if there is a chance of since we are making use of our own exceptions, we have to manually throw it. So we have to manually throw that exception with some error message. This will be the error message. This is the error message that will be displayed when this particular exception is thrown. So when my exception is type is created, that exception is created. So this has to be our error message. Okay. So this statement. So this statement will be taken here. Okay. So this is the exception. So when we here, what is happening here? It is creating an object of my exception type. So the constructor will be invoked, and this message will be stored into string 1, right? So it will be stored into string 1, and then when you try to display it, you're catching that exception inside. So once this is here at this statement, the exception is being thrown, and that has to be caught by it has to be handled. So it has to be caught by the catch block. So we are catching the exception of my exception type into the object exp, and we are displaying it, right? So when you displayed this, whatever statements was there inside that exception object has to be converted into toString. So that is why we are overriding the toString. So when you try to display this object, exception object, the toString method will be invoked, and that statement will be occurring inside the as the output. So that is why we get this whole. That is why we get this whole statement. We have we have my exception occurred, which was obtained from here, and this is my error message which was created at the time of exception object creation. So this is how we create our own exceptions. And that's about creating our own exception. So whenever we try to create our own exceptions, we have to extend the exception class and you have to manually throw the exception. Because since Java don't know that, so this exception, since Java JDK doesn't have this exception already built in it, it doesn't know that this exception is possible. So that is why we are manually throwing that exception. So to prepare today's slides, I have made use of the textbook Complete Reference 9th edition and the websites Java T-Point and the tutorial of Oracle, Java Oracle tutorial. So in today's class, we have discussed about finally, the use of finally block, what are the different built-in exceptions in Java, and how we can create our own exception, how the users can create own exceptions. So that is all for today's class. We'll see in the next video. Thank you for watching my video.
Like, share and subscribe. Hit the bell icon for more updates.